In the age of AI and touchscreens, how has a humble pencil costing mere cents managed to defy obsolescence, with a staggering 14 billion still produced every single year? Beneath its deceptively simple appearance lies a manufacturing process of extraordinary mechanical precision. The journey begins as a finely blended mixture of graphite and clay is extruded, then fired into durable pencil cores, engineered to achieve the ideal balance of strength and smoothness. At the same time, premium cedar slats are milled with precisely aligned grooves, forming a protective wooden shell around each delicate core. High-speed cutting systems then carve and shape the bodies with remarkable accuracy, before multiple layers of glossy coating transform these raw materials into flawlessly finished pencils. Today, join the Factron process as we uncover the remarkable engineering hidden inside one of the most familiar pieces of stationery on the planet. The monumental legacy of the modern pencil ignited from the discovery of pure, pristine graphite deposits in Borrowdale, northern England. However, it was Nicolas Jacques Conté who engineered a revolutionary breakthrough in the late 18th century by masterfully fusing graphite with clay, laying the immutable bedrock for global manufacturing that we see today. From a rudimentary utensil, the pencil has scaled into a global powerhouse, capturing a massive market that is currently touching an incredible $8 billion USD. Defying the unstoppable digital tide, it remains the ultimate, indispensable weapon for carpenters, engineers, architects, and artists alike. Yet, behind a fleeting lifespan of just a few weeks on paper lies a truly profound ecological challenge. The majestic trees harvested for its wooden shell require a staggering 20 years to mature. To sustain this delicate environmental equilibrium, Faber-Castell in the US steadily regenerates 300,000 fresh saplings every single year. Ultimately, the true epic journey of a single pencil begins decades before it ever leaves its very first mark on the world. The journey of making a pencil begins by transforming graphite and clay into an almost perfectly homogeneous mass. First, a dosing machine weighs each ingredient according to the grade of lead being produced. Increasing the clay content makes the lead harder, allowing it to hold its point longer, but producing a lighter line. When the proportion of graphite is increased, the lead becomes softer and darker, gliding more smoothly across the paper. From the storage hoppers, the dry ingredients blend with water and feed directly into the chamber of a large twin Z-blade mixer. The secret lies in the asymmetrical motion of the two blades, which rotate in opposite directions at completely different speeds. While the faster blade reaches 42 revolutions per minute, the slower blade operates at only 28 revolutions per minute. This difference continuously stretches, folds, and rolls the material from one blade to the other, rather than allowing it to simply spin aimlessly inside the mixing chamber. The material leaving the rolling machine is fed directly into the cylinder of the extruder. A hydraulic piston moves forward, generating a pressure of approximately 400 kilograms per square centimeter, enough to force the dense mixture through a series of tiny die openings. On the other side, the material emerges as long, continuous strands of pencil lead. Although these strands already have their familiar shape, they are still moist and extremely soft. As the strands reach the end of the machine, an automatic cutter divides them into equal lengths and arranges them on trays, ready for the drying and firing stages. The lead segments leaving the extruder have only taken on the shape of pencil leads, while the water still trapped inside keeps them soft and highly prone to bending. The trays are therefore placed in a drying chamber, where the temperature gradually rises to 284 ferrofaros, allowing the moisture to escape slowly and evenly. If the surface dries too quickly, the leads may shrink before their inner cores and crack during the next stage. Once the water has been removed, the trays move deeper into the kiln, where temperatures range from approximately 1,472 to 2,012 ferrofaros. The intense heat hardens the clay into a structural framework that holds the graphite particles together, transforming the soft lead rods into a material strong enough to withstand assembly and sharpening. After cooling, they are therefore immersed in a bath of hot oil or wax at approximately 109 Fahrenheit. The liquid gradually penetrates the microscopic pores, helping the pencil write more smoothly before the leads are transferred to the wood assembly line. while the pencil leads are being completed inside the factory. The journey of the wooden body begins in forests hundreds of miles away. For premium pencils, one of the most highly regarded choices is incense cedar, grown in the mountainous regions of California and Oregon. This wood has a fine, stable grain and is easy to machine, allowing milling cutters to produce a smooth surface, while sharpeners peel away long strips of wood without causing the lead inside to snap. In certified managed forests, trees that have reached harvesting age are marked before being felled. The trunks are then delimbed, cut into sections, and transported by truck to the sawmill. However, not every part of a log can become a pencil body. Debarking and primary sawing machines must first remove sections that are curved, cracked, decayed, or contain too many knots, because even a single area of misaligned grain can cause the sharpener blade to change direction later. The acceptable wood then passes through a multi-blade saw, where each large section is divided into straight, uniform blocks of pencil stock. From there, the blocks are softened and cut into slats approximately 7.24 inches long, the basic dimensions needed to form the two halves of the pencil body. The wood blocks leaving the sawmill are still too hard to be cut into thin sheets without tearing or splitting the grain. Therefore, at facilities that process the wood from the beginning, they are placed in a steaming vat at approximately 158 degrees Fahrenheit, allowing the heat to gradually penetrate the internal structure and soften the grain before slicing. Once the wood fibers become softer and easier to machine, each block moves on to a planer, and then a slicing machine, where long blades cut it into flat, uniform slats. Each cut produces a slat approximately 7.25 inches long and only about 0.25 inches thick. Its surface must be flat enough for the two halves to close tightly together, because even a slight warp can push the lead away from the center of the pencil. The slats are then stacked into ventilated bundles and dried until their moisture content stabilizes. Only flat wood proceeds, since any distortion would reduce the accuracy of the lead grooves. Once the thin wooden slats have retained their flatness after drying, they enter the stage that determines the position of the lead inside each pencil. Each slat is pressed firmly against the machine bed by rollers, then pass through a continuously rotating multi-spindle milling cutter assembly. Instead of cutting each groove separately, the parallel blades create 5 to 9 grooves simultaneously in a single pass, allowing the entire surface to be machined in just a few seconds. A modern integrated system can process up to 60 slats per minute, using a motor rated at approximately 11.4 horsepower to maintain a stable speed for both the cutter assembly and the feeding mechanism. Behind the cutting zone, dust extraction ports remove sawdust to ensure the adhesive bonds directly to the wood. The newly milled grooves are where the finished leads from the adjacent production line are inserted. First, a dosing system applies a very thin layer of water-based adhesive along the grooves and across the wood surface. The adhesive commonly belongs to the PVAC or VAE family, allowing it to bond the two wooden slats firmly while also holding the leads securely inside the grooves. The lead placement machine then positions each graphite lead correctly before a second slat is placed on top, enclosing the entire row of leads. On a high-speed drum line, the adhesive application, lead placement, and top slat assembly process can reach 60 to 90 sandwich blocks per minute. The sandwich blocks are then stacked inside a hydraulic press frame. In a two-component adhesive process, they are held at a pressure of approximately 100 to 145 psi for nearly 2 hours, enough to press the two wooden surfaces together evenly without crushing the slender leads inside. Once cured, the adhesive not only locks the two slats into a single block, but also distributes impact forces along the pencil body, reducing the risk of the lead breaking or separating from the wood during sharpening. Once the adhesive has cured, the sandwich block still looks like a flat wooden board, but inside it already contains an entire row of parallel pencil leads. This is when the familiar shape of the pencil begins to emerge. Each block is pulled into the shaping machine by rollers and held firmly in place as two rotating cutter assemblies approach from above and below. Rather than stamping the shape, the blades progressively remove the excess wood around each lead. The upper cutters form one half of the pencil body, while the lower cutters finish the remaining surfaces and simultaneously separate the entire block into individual pencils. By simply changing the cutter set, the same production line can produce hexagonal, round, or triangular pencil bodies. The newly separated pencils are then guided directly into a smoothing system, where their surfaces are sanded and lightly pressed to remove wood splinters and cutting marks. Within just a few seconds, what was once a flat wooden board has become an entire row of unfinished pencils, neatly formed, firmly assembled, and ready to continue to the next stage of the manufacturing process. After the unfinished pencils, still showing their natural wood color, leave the smoothing machine, they are sent to a multi-coat painting line to add color, enhance gloss, and protect the surface from dirt and moisture. Here, the nearly 40-foot-long system operates continuously, meticulously applying a primer coat to conceal the natural wood grain, followed by a color coat to create the desired appearance, and finally, a sleek varnish layer for optimal surface protection. Rather than applying one thick and heavy coat, the advanced machine pushes each individual pencil through high-pressure spray heads to coat them with 4 to 10 ultra-thin layers. Between these successive applications, 3 groups of specialized heating pipes continuously circulate hot air through an optional drying chamber capable of holding up to 40,000 pencils at once, allowing them to dry almost immediately. Furthermore, the system incorporates smart sensors that automatically halt the feeding mechanism if a pencil becomes jammed, successfully preventing the rollers from leaving any unwanted marks on the still soft paint. At the end of this seamless process, compressed air jets forcefully propel the finished pencils out of the painting machine. Immediately at the output, workers conduct a quick visual inspection and carefully sort the pencils by color intensity before transferring them to the next stage. After the coating process is completed, all the pencils are automatically transported to the finishing area by a vertical tray-type chain conveyor, which keeps them aligned for continuous feeding into each downstream machine. The first stop is the hot stamping machine. Here, a roll of colored metallic foil, known as hot stamping foil, is drawn between the stamping die and the pencil body. When the heated metal die presses down for a fraction of a second, the ultra-thin color and metallic layers on the foil adhere only to the contact areas, creating the brand name, product code, and hardness designation, such as HB or 2B. The temperature, pressure, and pressing time must be precisely controlled to ensure that the lettering transfers evenly without deforming the newly finished paint layer. For models without erasers, the ends of the pencils are briefly dipped into a bath of water-based paint or colored acrylic paint to create an identifying color band. Workers then arrange the pencils on trays and place them in a circulating drying chamber for approximately 2 hours, allowing the paint to dry completely. For models fitted with erasers, an automated machine feeds cylindrical erasers made from synthetic rubber or vinyl. At the same time, a vibratory bowl feeder supplies individual aluminum or brass ferrules, which are pressed tightly around the wooden bodies before small ridges around the rim are crimped to secure the erasers firmly in place. Finally, hundreds of pencils are fed into an automatic sharpening system. Each pencil is held steady and rotated evenly by rollers as its tip advances into a shaping cutter. The wood and paint are removed in thin layers to form a cone until the graphite core is exposed at the center to the specified length. Wood dust is continuously extracted, while pencils with off-center leads, unevenly sharpened tips, or chipped surfaces are automatically rejected from the production line before packaging. Before leaving the production line, every batch of pencils must pass a strict quality inspection to ensure that each product meets the required standards for appearance, structure, and usability. First, workers visually inspect each batch to detect obvious defects such as bent or cracked bodies, missing paint, uneven coating, or misaligned printing. Several pencils are selected as samples for sharpening and writing tests, as well as to check whether the lead is properly centered, produces a consistent line, or breaks easily during use. To evaluate the durability of the paint layer, the samples are then placed in a pencil hardness test device. The pencil is fixed at a standard angle, allowing the lead tip to slide directly across the painted surface. As the device moves in a straight line, the pencil tip applies even pressure to the coating, simulating a controlled scratch. This allows the factory to assess whether the paint has sufficient adhesion, hardness, and scratch resistance. If the surface shows deep scratches, peeling coating, or abnormal marks, the sample is rejected. Only pencils that meet the required standards are moved on to the final packaging stage. The pencils that pass the final inspection are gathered by guide channels into even rows and fed into an automatic counting system. Depending on the product, the machine divides them into sets of 6, 12, or 24 pencils before a pushing mechanism gently slides the entire group into a box. The pencils must all face the same direction, so the sharpened tips do not collide with one another, and the printed text still faces outward when the user opens the box. On a high-speed production line, the machine can complete between 30 and 120 boxes per minute, while also printing the batch code and checking the quantity before sealing the lid. The small boxes are then packed into cartons, labeled, and placed on pallets. Finally, the cartons are labeled, stacked onto pallets, and moved into the distribution warehouse, ready to be shipped to hundreds of countries around the world. And that is the complete journey of making a pencil, a familiar object used by people all over the planet. Behind its simple appearance lies an entire process of precise manufacturing. If you still have any questions about this process, leave a comment below. Don't forget to subscribe to the channel, like this video, and we'll see you again in the next journey with Factron Process.